Welcome back to section 3.2. This will be our second day on here, doing a few more examples. And today we're actually going to graph a logarithmic function. And it says here to sketch the graph of y equals log base a of x, you can use the fact that the graphs of inverse functions are reflections of each other across the line y equals x. So it says here in the same coordinate plane, sketch the graph of each function. What we're going to do is sketch this one, 2 to the x, and then we're going to switch the x and the y coordinates, and when we do that, it'll turn into the log base 2 of x graph. Okay, you might remember this one from the 3.1 video. If we do x is 0, 2 to the 0 is 1. If x is 1, 2 to the first power is 2. If x is 2, 2 squared is 4. If x is 3, 2 cubed is 8. And if we go negative, 2 to the negative first is 1 over 2, or a half. Negative 2 would be 2 to the negative 2, or 1 over 2 squared, 1/4. And that gives us enough points. I'm going to hop over to the graph and graph those. So we do 0, 1, 2 to the first, 2 squared, 2 cubed. And then to the left, 2 to the negative 1 would be half, and then we have a 1/4. So there is our 2 to the x graph. If I go back here, again, this was labeled as our x's, and then f of x could also be called our y values. So when we graphed those x's and y's, it was 2 to the x power. Now I'm going to go back, switch to red ink, and just reverse the x's and the y's. So I'll use the bottom row as my x's, the top row as my y's. Back to here, so this point 0, 1 is now 1, 0. The point 2 or 1, 2 is now 2, 1. We had a point on the blue graph. Let me write these up there. We have this point here that's 2, 4. On our log graph, that'll be 4, 2. Up here we had the point 3, 8. That is now 8, 3 on our log graph. And then for the fractional ones here, we had negative 1, 1/2. Now we'll do 1/2, negative 1. And this last point way down here was negative 2, 1/4. So we'll go 1/4 down to negative 2. And here is the log graph. Log base 2 of x. And abracadabra, I added in that dotted black line. If I back up here, it says, remember that inverse functions are reflections across the line y equals x, and that is the line y equals x, 1, 1, 2, 2, 6, 6. You know, we go diagonally through the grid, and that is just better shows how these points are reflections. 2, 4, and 4, 2. 3, 8, and 8, 3. They're just reflections across that line, like any other inverse function. And I think that's all they wanted us to do for that one. Yes. Okay, example 6. Sketch the graph of the common log function, log base 10 of x. Identify the vertical asymptote. Now here in the box, we've got the option. We're going to do some numbers without a calculator and some numbers with a calculator. Like this, block that off. And let's see, what's some good ones without a calculator? Well, let's do, of course, first power. 10 to the, or 10 to what power? Or no, let's do it like this. 0, 1, exponent 0 equal to a 1. We could do exponent 1, 10 to the first is 10. Negative 1, that would be 1/10. Negative 2, that would be 1/100th. Now, we can do these on the graph. We got these again without a calculator. If I hop over here, we would have 1, 0. We would have, what was the next one? Over 10 up 1. And then we had 1/10 negative 1. and 1/100th negative 2. That would be even closer to the y-axis. So here again on our graph, we've got the important stuff. We do have the x-intercept, and we can see we're approaching the y-axis but not going to touch it. But, for a good graph, we might want some extra points. So we could always fall back and use a calculator. Like, let's find 2, 5, and 8. If we go to our calculator with the common log and type in 2 and hit the log key, you're going to get 0.301. So 2 comma about a third. Over 2 up a third, that's less than a half, so maybe right there. Oops, wrong way. Let's try again. 5. 5, hit the log key, you get 0.699, about 0.7. So let's go over to 5 and go more than halfway up to 1, 0.7, maybe about right there. And the last one, let's do wrong way again. 8, hit the log key, you get about 0.903 or 0.9. We're just below the line y equals 1. So here at 8, we're right below the line. And those points, do line up nicely with our others. We're just kind of double checking with some calculator points. And the common log graph would look like this. The log of x, log log. All right, that was fun. Oh, and it did say, I almost forgot. Identify the vertical asymptote. If we look, oh, wrong way again. If we look here, we are approaching, but it doesn't look like we're ever going to touch that y-axis. And remember, this function here is the log of x, the log base 10 of x, or the log of x. And to find the vertical asymptote, here it is the y-axis, because this is just x. Whatever's in those parentheses, set that equal to 0, and that is where the vertical asymptote will be. So if we go back to here, identify the vertical asymptote. Again, this is log of x, log of x. We just set what's in there equal to 0, and that's our vertical asymptote. And the graph backed it up. X is 0, that's the y-axis, and we're not going to touch that y-axis with our function. Okay, here's some stats on our log graph. The domain is 0 to infinity. We're not shifted, so we have a y-axis asymptote, and we're going to head this way forever, but we're never going to go negative. Our range on the y-axis, positive to negative infinity. Anything can come out of a log, but only positive numbers could go in. If you're not shifted, you do have an x-intercept at 1, 0. And remember, that's just the reflection of the exponential y-intercept. Exponentials all cross at y equals 1. The function is increasing all the time. As we go left to right and draw on the graph, we're going uphill the whole way. It's 1 to 1, therefore it does have an inverse. We already know that's the exponential. And it does have a vertical asymptote of negative infinity as we approach 0 from the right side. So as the graph is coming in from the right side, we're headed down, down, down. We're headed down toward negative infinity. All right. Let's see here. The graph of each function. Shifting graphs of logs. The graph of each function is similar to the graph of log x. I believe the book just wants us to tell us how it's been shifted. Let me just do a quick graph here. We've got log of x. I'll do that in red. So here's our regular old log of x. It goes through 0, 1. And now here we've got a shift. Log of x minus 1. Notice we're messing around with the x variable before we do the log operation. So this is going to be a left or right shift. And this is also going to, be, in theory, move the vertical asymptote. So if that's a minus 1, remember it's sort of counterintuitive, that's going to move our graph to the right 1 unit. So let me switch to black ink. Our new graph will have a x-intercept at 0, or this should have been 1, 0. What was I doing? 2, 0 for our new intercept. And then the graph would look more like this. And I also mentioned before we can find the asymptote if we set what we're logging, x minus 1, equal to 0, and solve for x, we would add 1 and get x is 1. That is now our new vertical asymptote. So I'm going to use red ink and draw this dotted line for the vertical asymptote. Here our old graph went through that as an x-intercept, but since we shifted everything 1 unit to the right, the vertical asymptote that was the y-axis is now this line at x equals 1. Okay, and here we've got our log of x. Notice we're adding or subtracting after we're done logging. So this is a shift up or down, and they could put it over here, x plus 2. As long as they don't have the parenthesis around that as a quantity, we're going to take the log of x graph and shift it up 2 units. So bada boom, bada bing. Here's our log of x graph unshifted. Y-axis asymptote goes through there. And now we're just going to shift everything up 2 units. So this x-intercept here is up 1, 2. Now it's right here. And we still have the y-axis as our vertical asymptote. And we're still going to head up and to the right. Checkpoint. Try some of these out. Here you're going to do log base 3 of x. Graph that on the xy axis here. And then down below you're going to take that graph and do a couple of shifts to it. Remember, the easy way to graph this one, you could do 3 to the x. I would do like x is 0, 1, and 2, negative 1, negative 2. Get your y values and then switch them. Again, here's x, here's y. For the exponential, to do the log graph, just reverse those x's and y's. So pause the video and give that a try. Okay, 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9. And then we can just reciprocal those. At negative 1, it'll be a third. At negative 2, it'll be a ninth. So the graph should look a little something like this. 1, 0, 3, 1, 9, 2. And then we've got our fractions as we approach the y-axis. So the blue graph is our log base 3 of x. If I come down here, I'll switch to red. This g of x is the graph we just did, but we're going to subtract 1. So easy thing to do is just drop every point down by 1 spot. This goes down here. Our new x-intercept is 3, and now over at 9, we're just at a height of 1. And then our fractions get knocked down here. So there's our red graph of log base 3 of x minus 1. And now here we've got log base 3 of the quantity, x plus 3. So let's figure out where our shift is. It looks like we're going to go to the left 3 units. And I should have clipped a little more of this graph. I'm going to put negative 3 right about here. So everything gets moved 3 units. Remember, the y-axis was our old vertical asymptote. So now negative 3 is our new vertical asymptote. Black ink. We had this old x-intercept at 1. That is now moved to negative 2. This point here, 3, 1, is 3 to the left. So now that's our new y-intercept. This point out that was out here at 9 now just goes to 6. So here is our graph shifted 3 to the left. And there we go. Beautiful. Oh, and all good things must come to an end. That's the end of the video. You know the routine. We'll do some odd problems in class to practice, and then have a little fun on WebAssign.